guys, welcome back to chapter 4. In this video, we're going to start talking about some exceptions to the rule. So up until this point, we've talked about main group elements. Elements that follow the rules of creating charges that we predict. What we're going to talk about now are two exceptions to the rule. The first exception to the rule is going to be our transition metals, those D block metals that march to the beat of their own drum. The next video is going to be the second exception to the rule, and that's going to be something called polyatomic ions. So transition metals, what we see here in the middle is just a big mess, right? So we see that transition metals can form more than one type of ion, and the type of ion that they form really doesn't have a whole lot of rhyme or reason. So here we see iron can be a +2 or a +3. Copper can be a +1 or a +2. Down here we've got lead is a 2 or a 4. So we see a whole lot of options. So when it comes to naming with transition metals, we have to have an extra layer. We either have to tell the viewer what the charge is on that transition metal, or we have to be told what the charge is on the transition metal. So there's an extra step in the naming process. So for transition metals, the way that we do this is with Roman numerals. So we will write the name of the metal, that's the same as before, and then we will add this Roman numeral telling the viewer exactly what the charge is on that metal. So here we see iron with a Roman numeral 2. That's going to indicate that the iron has a +2 charge. Here we see tin with a 2. Again, +2 charge. Here we see cobalt with 3. That would be a +3 charge. So if we're writing the name, we need to make sure that we include the Roman numerals. If we're reading the name, we just use the Roman numerals to tell us what the charge is. We don't really have to think any at all. We just use that number. So here is how we are going to handle naming of transition metals. We're going to write the name of the metal. That's exactly the same as before. We're going to write the base name of the nonmetal plus IDE. That's exactly the same. So blue, green, exactly the same. What is new is this yellow guy in the middle. So we're going to have to write the charge of the metal in parentheses in Roman numerals. Okay. So let's take a look at an example. So both of these compounds exist. In one of them, copper is attached to 1 chlorine, and the other one, copper is attached to 2 chlorines. Both of them are viable compounds. Let's write the name of them. So we're going to do the one on the left first. We're going to do this one. So the first thing that we're going to write down is we're going to write the name of the metal. So we're going to write copper. I'm going to leave a space for the Roman numeral. Then we're going to write the base name of the nonmetal plus IDE. So that's chlorine. Base name is chlor. Add IDE. Now we need to go back and we need to tell the viewer what the charge is. The thing that we're going to use is the fact that this formula is electrically neutral. So chlorine is one of our main group elements. It's very predictable. It always has the same charge. So it has a -1 charge, always. If this is, in fact, electrically neutral, and it is, we now need to predict what the charge is going to be on this copper. So if chlorine is a -1, this one individual copper must be a +1 to balance that out. +1, -1, and those are neutral. So we would write a Roman numeral 1 in the middle. The way that we would read this is copper 1 chloride. Now let's look at this guy over here. Okay. So we're going to do the same thing. Write the name of the metal, copper. Write the base name of the nonmetal plus IDE, so chloride. And now we need to decide what the charge is on this particular atom of copper. So again, we're going to use chlorine. Chlorine's very predictable. It's always a -1. But now we see that there's 2 chlorines. So 2 chlorines each bring a -1 to the table. We're multiplying these numbers. Excuse me. There's a total of -2 charge. So each chlorine brings a -1 to the table. There's 2 of them. So altogether, that's -2. Over here, I see that I still only have 1 copper atom. This copper atom must have a +2 charge in order to balance out the -2 that chlorine brings to the table. So this one has a +2, that's why we need 2 chlorines. So the way that we would write that is a Roman numeral 2 in parentheses. So the name of this compound is copper 2 chloride. Okay. So again, transition metals can have multiple charges. If we're writing the name, we need to make sure that we tell the viewer what the charge is on that transition metal, and we do that with Roman numerals. If we have the name, like copper 1 chloride, we don't have to think. If we're writing the formula, it tells us, hey, it's a +1. So less to think about. So that's our first exception to the rule. That's our transition metals. I hope you guys found this helpful.